All right, it's time to learn about some important derivatives. Now, these two boxes here, you're going to have to just memorize these. For this one, we're going to do so many problems that you're going to have that to memory, maybe even possibly by the end of this video. This box here, I have a really cool way of remembering each of these. And so with that trick, it's not really memorizing, it's just kind of going through a process and then you know what it is. As for this box right here, if I ever asked you for the derivative of the inverse sine function or any of these inverse functions, I will give you those answers. So don't worry too much about those, but those derivatives do exist. Let's go ahead and let's focus on this first box. And if you haven't already, you might want to take some time to write each of these down so you can reference them in the future in your notes. All right, let's work on this box. So let's say we have something like y equals 2 times e to the x plus 4. Well, y prime is just going to be, well, what's the derivative of e to the x? Well, the derivative of e to the x is itself. It's just e to the x. So using the constant multiple rule, we would write down the 2 and then multiply it by the derivative of what I have boxed, and that's just going to be e to the x. Now the derivative of 4 is 0, so we don't write that down. So that's it. We're done. So just remember this, when you're taking the derivative of e to the x, it is just e to the x. Let's try another one. Let's have f of x equal to 3/4 e to the x plus 7x squared. Well, this is going to be f prime of x equals, well, the derivative of e to the x is just e to the x, and then don't forget to multiply it by that constant out in front. Constant multiple rule. And then this here is called the power rule, where we've been practicing this a lot, where you bring that 2 down in front. 2 times 7 is 14, and then be x to the first. We don't have to write to the first. All right, there we go with that. So we have practiced this first one, and just remember that the derivative of e to the x is simply e to the x. We're going to do that so many times that you will eventually have that memorized if you don't already right now. Okay, let's try another one. What if I had something like this? Y equals 4 ln x. What is y prime? Well, this is going to be 4. And then what's the derivative of ln x? Oh, it's just 1 over x. So that's our derivative, and we can certainly write this better. We can think of this as 4 over 1 times 1 over x, which is going to give us a 4 divided by x, and that would be our derivative. How about this one? What if we had f of x equal to ln x over 5 plus a 4x squared? Okay, well, we can rewrite this. Instead of saying ln x divided by 5, I can rewrite this as 1/5 ln x. And of course, we still have the 4x squared. So my answer, f prime of x, is simply going to be 1/5 times the derivative of ln x, which is 1 over x. And now we take the derivative of this, and that is an 8x. Simplifying that, well, multiplying across here, I get 1. Multiplying across here, I get 5x. And then we've got our plus 8x. All right, so I'm going to emphasize that again. When we take the derivative of natural log of x, that is simply 1 over x. We will have time to kind of look at why that's true when we look at derivative graphs, but we're not going to prove it algebraically. All right, next one I want to cover is the last one, and to be honest, this is the one that we use the least, and so I feel like I tend to forget it more, and so this one you maybe want to spend more time memorizing. So let's say y is equal to 7 to the x what is dy dx? Well, what is the derivative? Well, this says if I have a, which is a constant, a number, let's say 7 to the x, well, what we're going to do is rewrite it completely over again. So it would be 7 to the x. But then you would write ln of whatever that a was. Remember, a is 7 to the x. So we'd have ln 7. So again, this would be rewrite the value itself and then write ln of 7. All right, let's try another one. Let's have f of x equals 5 times 2 to the x. Now, I know there's no parentheses in this, but there are implied parentheses, meaning that this is saying take 2 to the x and then multiply it by 5. So in reality, we have a constant multiple rule situation where we're just going to find the derivative of this and then multiply it by 5 out front. So our f prime of x is going to be equal to drop down our constant 5. Now what's the derivative of that? Well, that's going to be 2 to the x and then ln 2. Do not multiply these two numbers. This is being 2 raised to the power of x and then multiplied by 5. So it would be incorrect to write this as 10 to the x ln 2. That's wrong. All right, so again, I want to emphasize that this one here, we do need to have that to memory, but we're going to do it less than the other ones, and so you might have to put some time into memorizing it. All right, let's take a look at these. These are our derivative functions, and I feel like I have a really good way of remembering this. It's worked all throughout the years. And don't tell Mrs. Sears I said this, but notice how there is a c here. The derivative of cosine is a negative sign. So I think to myself to remember, I think that computer science is bad. Bad meaning negative, or maybe it's boring or it's hard, or, you know, something negative. So when you take the derivative of cosine, you get a negative sign. So think of that as when you're taking the derivative of computer, you get science and it's negative. All right, what about this one? How do I remember that when we take the derivative of a sine, a positive sign, we get a positive cosine? Well, of course, my good friend Santa Claus, he's a good guy. He's positive. He's good, right? So the derivative of sine is going to be cosine. So I do want you to have those to memory. We're going to do them a million times, and that's one that you need to know. The last 4, I have a way to remember this by. How are you going to remember that the derivative of tan is secant squared? And how do you remember that derivative of secant is secant x tan x, etc.? Well, of course, you would have guessed it. We use some sexy turtles. Yes, we do. They're looking good, don't you think? Looks like they're working out. So how does this help us? Well, this is how we do it. We write down SST, some sexy turtles. And if you're kind of more like a PG-13 person, you could call it some special trig, right? Because we are dealing with trigonometry. But if you're okay with PG-13 plus here, we can use some sexy turtles. So I write down my SST, and when I have my S, that tells me that I need to write down my trig value that starts with the S. I know you'd think sine, but here we're mainly dealing with our reciprocal trig functions. So we're going to write down secant. Again, we write down secant, and the T would tell us to write down tan. Okay, now completely ignore this section now. Now we're looking at these values, and we're basically going to write the co-version of it, meaning we're just going to smack a co onto the front. So if this says secant, right, this says secant right here, I would write this as a cosecant. Again, this says secant, so I'm going to write cosecant. Okay, here I've got a tangent, so I'm going to write the cotangent. of tangent. Now you might notice that there's a negative right here, and you know, throughout the years I've had ways to remember that, but I kind of like to say to myself, hey, I know I can draw a turtle like this. And oh, how sad. Okay, that's a turtle, right? So sad that this one gets left out of the drawing, so it's negative, it's sad. All right, so as a reminder, the S stands for secant, the S stands for secant, the T stands for tan. Then you do the co-version, cosecant, cosecant. Do the co-version of this, you get cotangent. And then draw your turtle guy, and you realize you're sad because this guy got left out of the drawing. Okay, how the heck does this help us memorize our trig derivatives? Well, what is the derivative of secant? Well, we look to the right, and the derivative is secant x tan x. Let's confirm that. The derivative of secant is secant x tan x. How cool. Okay, what's the derivative of tangent x? Well, what are the things next to it? A secant x times secant x, or secant squared x. So let's confirm that this is true. The derivative of tangent x is secant squared x. So that gives us the derivative of tan. Okay, now we go down below. What's the derivative of cosecant x? Well, that's going to be a negative cosecant x cotangent x. See it? It's right here. So the derivative of cosecant x is these two things multiplied. All right, and last but not least, what's the derivative of cotangent? Well, circling cotangent, it's going to be the derivative, it's going to be these two things multiplied, which is a negative cosecant squared x. A lot of students often say, hey, can you circle this thing and say it's this times this? No, we don't do that. All we do is say the derivative of this is these two things times. The derivative of this are these two multiplied. Similarly, we can box this one off and say the derivative of that is going to be this times that, and the derivative of this is this times that. All right, I think we need to do a couple practice problems with this, and we'll move forward with our lives. All right, so what if I have f of x equals negative 3 sine x plus 4 ln x? Well, maybe you want to pause this video and try it on your own. What is the derivative of that? Let's do it. So anytime we have a constant, I'm just going to rewrite that negative 3 down. And what's the derivative of sine? Remember, Santa Claus is good. So if I have a positive sign, which I do, ignore the fact that I've written down my negative 3, I've got a positive sign. So the derivative of that is Santa Claus, Claus being good. So I've got cosine x. Okay, and then what's the derivative of 4 ln x? Well, that'll be 4 times a 1 over x, which we know we can write as a 4 divided by x. All right, there we go. Let's try another one. What about g of x equals a negative cosine x plus 4 tangent x plus 6 times 11 to the x. What's the derivative of that? Well, first of all, we can think of this, if you want, as a negative 1 times cosine x. So you can think of it as negative 1 times. So I'm just going to drop down the negative 1. And then what's the derivative of cosine? Well, computer science is bad, so that's going to give me a negative sine x. Well, what's a negative 1 times a negative sine x? Well, that's going to give us a positive sine x. So I'm going to go ahead and erase that now. And that makes sense, because if you think about it, if we had, let me just change this back to the original. If we had a positive cosine x, we know that this should be a negative, but it's not. This problem actually says what's the derivative of a negative cosine x, okay, which is going to make this a positive sine x. All right, next thing we're going to do here is find the derivative of 4 tan x. So I drop down my 4, and now I need to find the derivative of tan x. So real quickly, I do some sexy turtles. So SST, secant, secant, tan, cosecant, cosecant, cotangent, put my negative. So now my derivative of tangent is a secant times a secant, which of course we know is secant squared x. There we go. All right, folks, you're going to have to practice this on your homework, and we'll certainly practice it in class. Definitely a lot of information, but you're all brilliant. Have a great day.